Welcome children to the chemistry class. We were doing organic compounds containing nitrogen, and in the last video we had done the classification and the nomenclature. In this video we are going to study about the preparation of amines. So let us begin the different ways of preparing amines. The first one could be by reduction of nitro compounds. Okay. Let's look at some of the reactions. For example, RNO2. This is your nitro compound. When treated with 3 molecules of hydrogen in the presence of nickel or palladium or platinum, and they're heated at room temperature, then it forms a primary amine, that is RNH2 plus 2H2O. It can also be reduced. This nitramine can also get reduced with iron in the presence of HCl. Okay, so over here 6 hydrogen nascent hydrogen is used in the presence of what? FeHCl, and it is also going to give you primary amine plus water, right? Then these nitro compounds, they can also get reduced by lithium aluminium hydride as well. Second way of obtaining amines could be by ammonolysis of alkyl halides, right? Now what is ammonolysis? The process of cleavage of your carbon and your halogen bond by ammonia molecule. This is known as Hoffmann's ammonolysis or ammonolysis of alkyl halides, right? Such reactions, they are carried out in a sealed tube at around 373 Kelvin, right? In reaction, the alkyl halides, they undergo nucleophilic substitution reaction. So look at the reaction. When your alkyl halide, it is treated with ammonia at what temperature? I told you 373 Kelvin. So what it is going to form? It's going to form RNH3X. Okay, this is the salt that it is going to form, and this is further when treated with more of ammonia. What it is going to form? This is going to give you the primary amine plus NH4X. Clear? Is this very clear? Now this primary amine, it acts as a nucleophile and it reacts with further with the alkyl halides, and it forms secondary, tertiary and your quaternary ammonium salt. Like for example, once this primary amine is formed, it reacts with the alkyl halide at temperature 373 and it will form secondary amine. Okay, then it can further be treated with more of your alkyl halide at 373. It will form your tertiary amine, and further again it can form your quaternary amine, that is R4NX minus, right? This method, it gives a mixture of so many amines, the primary amine, secondary and your tertiary amine, and therefore pure amine cannot be obtained by this process, and it is not suitable for even preparing your aryl amines. Why? Because the aryl halides, they are less reactive than your alkyl halides towards the nucleophilic substitution reactions. Next we move to reduction of cyanides. Reduction of cyanides. Okay, now let's look at this. Cyanide is RCN. This is what? This is your alkyl cyanide. Fine. When they are reduced, now I'm going to give you 3 different reactions, and this will be an easy way to remember. When your alkyl cyanide reacts with 2 molecules of hydrogen in the presence of nickel, or it can also get reduced with your nascent oxygen in the presence of lithium aluminium hydride, or even when it is reduced in the presence of sodium and mercury, right? In all these 3 cases, it is going to give us primary amine, that is RCH2NH2. This is your primary amine that is formed over here. Clear? Then even your isocyanide, alkyl isocyanide, that is RNC. What is this? This is your alkyl isocyanide. When this is reduced in the presence of lithium, aluminium hydride and ether. And ether, it is also going to give you amine, but what? Not the primary amine, but it is going to give you secondary amine, that is RNHCH3, and this is your secondary amine. I hope till here all the reduction is clear. Then next, the fourth one, that is the reduction of amides. Let's talk about reduction of amides. Okay, so let's look at the general reaction. RC double bond O NH2. This is your amide. When this is reduced in the presence of lithium, aluminium hydride and ether, right? What it is going to form? It is going to form your primary amine. This is going to form your primary amine. I hope all these reactions are clear to all of you. We now move to the next kind of reaction, that is the Hoffman's degradation reaction. Okay, let me rub this off. Then we move to Hoffman's. Yes, the fifth reaction is Hoffman degradation reaction. Okay, now in this we take the amide, that is RCONH2, and it is treated with bromine in the presence of KOH, right? And this, when heated, it forms your primary amine, that is RNH2 will be formed. Okay, along with some byproducts like potassium bicarbonate will be formed, potassium bromide will be formed, plus water will be formed. Here it will be 2 to 4, 4. Okay, then next one we come to Gabriel phthalimide synthesis. What did I say? Gabriel phthalimide synthesis. Now in this reaction only primary amines are prepared, right? Even the toluidine, aniline or any of your aromatic primary amines, they cannot be formed by this process. Is this clear? Now why they cannot be formed by this process? Because as we know, the aryl halides, they do not undergo nucleophilic substitution reactions with the anion formed by the phthalimide, and therefore they the primary aromatic amines, they cannot undergo this reaction. So let us look at this. We pay attention to the reaction that I am writing over here. So firstly, let us understand what is the formula of phthalimide. C double bond NH. What is this? This is your phthalimide. Okay, when this is treated with alcoholic KOH in the presence of water, what it is going to give? Because we are using KOH, so it is going to give us potassium phthalimide. So let us look at the structure of potassium phthalimide, right? NK. Is this clear? This will be minus, this will be plus. Further, when this is treated with any of your alkyl halide, it is going to give us N-alkyl phthalimide. So what is the structure of N-alkyl phthalimide? This double bond O, N and R. What is this? This is N-alkyl phthalimide. Okay, what was this? This was potassium phthalimide. Clear? When this is further treated with dilute HCl, right, under pressure, and more of water is added to it, that is, say 2 molecules of water when added, it is going to give us primary amine. What it is going to give us? It is going to give us primary amine, plus it is also going to give us the phthalic acid. What is the formula for phthalic acid? This C double bond or you straight away write it down like this, COOH, COOH. This is your phthalic acid. Is this clear to all of you? This was your Gabriel phthalimide synthesis. Then the next one was from the alcohols also. From alcohols. Now let us look at one of the general reaction, like alcohol when treated with ammonia. What? In the presence of alumina, that is Al2O3. At what temperature? 723 Kelvin. It is first going to form a primary amine, that is 1 degree amine. Further, when it is treated with more of aluminum oxide, and say we add more of alcohol, it is going to give us secondary amine. And furthermore, of alumina when added with more of alcohol, it is going to give us tertiary amine. Okay, let's look at one example over here. Say suppose if I take methanol, okay, like CH3OH, this when treated with NH3, what? In the presence of alumina at 723 Kelvin, what it is forming? CH3NH2, right? And further, this is treated with more of alumina along with alcohol, that is CH3OH that we are using. What are we going to get? We will get CH3 whole twice NH. Okay, further I have reached till here. Right, now I'm writing this reaction over here. More of alcohol is added in the presence of alumina. So alumina is here, more of alcohol, CH3OH. Finally, what is it going to form? The tertiary amine, that is CH3 whole thrice N. So a primary amine was formed, then a secondary amine was formed, and finally the tertiary amine is also formed by the alcohols. So this was all about the preparation of amines. Next we come to the physical properties. Aliphatic amines, or we may say the low amines with less than 3 carbon atom, they are usually in the gaseous state. 3 or more than 3 carbon atoms, they appear in the form of liquids, and still higher carbon atoms, they are in their solid states. Clear? Then amines, they are polar compounds, and both primary and secondary amines, they form intermolecular hydrogen bonds, but not the tertiary amine. Tertiary amines, they do not form the intermolecular hydrogen bonds. Why? Because they do not have hydrogen present in them. Clear? Next, they have higher boiling point than alkanes, but their boiling point is lower than alcohols. Then next important point is that since there are no hydrogen atoms in the tertiary amines, therefore they do not form any hydrogen bonds to each other. But yes, they form hydrogen bonds with the molecules of water. Therefore, they boil at a very low temperature than your 1 degree or your secondary amine at of a comparable molecular weights. Okay, because more of water molecules get attached to your primary and to your secondary rather than with the tertiary amines. Therefore, they because hydrogen bond within the tertiary amine is very less, therefore at lower temperature they easily boil up. So almost all the alkyl aluminum chlorides or your lower aliphatic amines, they are all soluble in water. Okay, your bromides, your alkyl aniline bromides or sulfates, they're all soluble in water. Why so? Because they are capable of forming hydrogen bonds with water. I hope the physical properties is also clear. Next we move to the chemical properties. In chemical properties, I'm going to deal with only the first point, and rest I will come up in the second video. Talking about now chemical properties. Now, if we check the structure of all the primary, secondary and your tertiary amines, what did we find? We found that they all had the nitrogen in all the structures of amines, they had lone pair, and there was a acidic hydrogen also present. Is that clear? Therefore, there are two reasons for amines to show reactivity and the chemical reactions. What are they? Firstly, it has a lone pair. It can donate electrons and therefore it behaves in two ways. What are they? The first is as a base. Why do amines behave as a basic in nature? Because they are capable of electron donation, because as electrons are donated. Okay, then they also act as nucleophile, as a nucleophile. Okay, so today I'm going to deal with the basic character of amines. The first point that we need to study in the chemical properties of amines, that is the basic nature of amines. Right? So let's begin to understand why do they show basic nature. Firstly, it is due to the lone pair. Clear? Then next important point that you need to remember is bases, when they react with acids, they form salt. Fine. So let us take one example. Suppose if I say that amines are basic in nature. So let me take this primary amine, which I say is basic in nature, and this reacts with an acid, say H and X, right? This is a mineral acid. So what will happen? This lone pair, they donate this lone pair, and what happens? This hydrogen is taken away due to electrostatic force of attraction, and what it is going to form? It should form a salt. What kind of a salt? NH3 plus X minus. Okay, this is the salt that is formed. Even the aryl groups, they also undergo the same reaction, the same process. That is, I take aniline over here, suppose, and this is treated with your acid, say H and X. So it is going to form a salt. What is that salt? Okay, NH3X. Okay, this is also the salt formed over here. So we can obtain amine back from these salts. Okay, with the, if the salt is treated with NaOH. Let's see how. If I take my primary salt over there, like RNH3X, this is plus, this is minus, and it is treated with NaOH. Okay, so look over here, what it is going to form. How OH is there, one hydrogen from here, so it is going to give back your primary amine, that is NH2 plus NaX plus H2O. Your primary amine is given back. Similarly, let's take one example like RNH3Cl. This is minus, this is plus. When treated with NaOH, so what should be our products? One H is given away from here, so this becomes your RNH2. This is your 1 degree amine that is formed, plus NaCl plus H2O. Okay, but the order of the basic strength for different amine is different. To check the basic strength of the amine experimentally, let's see how it was done. Firstly, the aqueous solution of amine was prepared. So let's take this primary amine, okay, which is acting over here. This is your 1 degree amine, which is your Lewis base. So it acts as a Lewis base. Okay, and here we take water. Water shows or acts as an amphoteric acid, but here it is going to act as a acid. Here this amine is acting as a base, and this is going to act as an acid over here. And what is it going to form? It's going to form RNH3 plus OH minus. The formation of this OH minus, or the formation of this hydroxyl group, means the aqueous solution of amine, is basic in nature. I hope this is very clear. Now let us understand the equilibrium constant and check the basicity of the amine. So according to according to law of mass action. What do we know? According to law of mass action, the dissociation constant, that is Kb, is equal to, according to this reaction, RNH3 plus OH minus upon RNH2. Clear? Or we can also say that OH minus is equal to the dissociation constant into RNH2 upon R plus NH3. Is this clear? So over here, what do we know? As the value of your dissociation constant increases, the concentration of OH increases. If the concentration of OH is increasing, therefore basic nature is also increases. Basic nature also increases. Is this point very clear to all of you? But we calculate the value of your dissociation constant better in this form, in pKb form. And what is pKb? It is equal to the negative logarithm or to your dissociation constant. Okay, so what can we say? That if your dissociation constant value is high, then your pKb value will be low. Okay, if your dissociation constant value is high, then your OH hydroxyl ion value will be high, therefore basic nature will be high. But if your pKb value will be low, then your hydroxyl ion will be high, and therefore the basic nature will increase. So when will your basic nature increase? When your dissociation constant is high or your pKb is low, then we can say the basic nature has increased. Is this clear? So experimentally, the basic strength of different compound was calculated and their basic nature was even studied. Now let us compare between ammonia and alkyl amine after rubbing this. Now, if we compare the basic nature between ammonia and the alkyl amines, so we know that it is given that the pKb value of ammonia, right, it is around 4.75, and that of 1 degree or 2 degree or even 3 degree, the range is from 3.75 to 4.22. So what did we learn just now? That if the pKb value is low, then OH value is high, therefore basic nature will also increases. So over here basic nature will be of what? Of this will be more than ammonia. Hence amines are more basic in nature than ammonia. Is this very clear? Another thing to make it understand more clearly could be if I write down the formula of ammonia over here and talk to you about its plus I effect. So what do you see in this ammonia? There is no plus I effect over here. Whereas if I write down the primary amine over here, it shows one plus I effect. Okay, what is that plus I effect? It means to push the electrons more towards the nitrogen. Thus when we donate thus whoever will donate electron will be more basic in nature. Therefore over here we can say that amines are more basic in nature than ammonia. I hope these 2 points are very clear. Firstly, the pKb constant of ammonia and amines can be compared, and then we can talk also on the basis of plus I effect, because ammonia has no plus I effect and the amines, they have plus I effect, therefore they are more basic in nature. Now coming to comparison of the basic property between the 3 amines. Okay, so this depends upon 3 important theories. Okay, the basic strength basic strength of amines depends upon three basic properties. What are they? The first is plus I effect, right? The second is the solvation theory or the solvation concept, we can say, and thirdly the steric hindrance. Okay, these are what we are going to study further. So let us talk about first point, that is the plus I effect. Okay, now this plus I effect is usually found in the gaseous phase. In the gaseous phase. Okay, this point is to be understood carefully. So plus I effect is preferably used in the gaseous phase. So over here the basic nature means what? To donate electrons easily. So look at the primary amine R, N, H and H over here. Then I'm writing about your secondary amine, and thirdly your R, N, R and R. Now let's talk about plus I effect. Over here if you see, plus I effect is only 1, right? Over here what do you see? Plus I effect is how many? 2 plus I effects. Here how many? 3 plus I effects. So which one is more basic in nature over here? Which one is more basic? Tertiary amine is more basic than your primary amine. So what can we write? This is more than, tertiary amine is more basic than primary amine over here. Okay, next we come to the second theory. What is our second theory? The solvation theory. The solvation theory says what? Or the solvation concept, it states that the compound, the amines which is more soluble in water shows more basic nature, right? So if you look at your primary amine, so if I write down your primary amine over here, it has more of hydrogen atoms present. Clear? Suppose this is R, H, H and H, and if I write R, N, H, H and R, and if your tertiary amine is R, N, R, R, and this is your H. Okay, now look at the solvation theory. What did I say? Which of these amines will be more soluble in water? Now look, for more solubility of water we need more of hydrogen bonding. So this is your primary amine, this is secondary, and this is your tertiary amine. Here we find more hydrogen, means more of your hydrogen bonding will be found over here. Here only 2 hydrogen bonding, and here only 1 hydrogen bonding. So whichever amine dissolves more in the water is more basic in nature. So what did we study over here? That primary amine is more basic than secondary and than the tertiary amine. Okay, next we come to the third theory. What is the third theory? Steric hindrance. Steric hindrance. Okay, now what do we know about steric hindrance? We know that in the primary amine there is no cloudiness, there is less steric hindrance, and if you look at the tertiary amine there is more steric hindrance. So what do we see over here also? That over here your primary is more basic in nature than your secondary, than your tertiary. Clear? So what did we check? We checked the solvation theory and checked the steric hindrance theory. They both show the same basic property, that is, in both these cases what do we study? That your primary amine is more basic than your secondary, than your tertiary. But if they are in the gaseous state, yes, this was in the aqueous state, I forgot to tell you, this is in the aqueous phase and this is in the gaseous phase. So in the gaseous phase your tertiary amine is more basic in nature than your primary amine, whereas in the aqueous state primary amine will be more basic than your tertiary amine, and your steric hindrance also, due to steric hindrance your primary amine will be more basic than your tertiary amine, right? Now your R group, the substituent R group also plays a very important role to understand the basic strength of the amines. So if we take a bigger alkyl group, okay, if we take a bigger alkyl group, say for example, if I take C2H5, right? If we take this, then in this case, what do we see? That C2H5 whole twice NH, which is your secondary amine, is more basic than your tertiary amine, that is C2H5 whole thrice NH3. This is your tertiary amine than your primary amine, that is C2H5 NH. Okay, this is your, so over here if we see, if we take a bigger alkyl group, bigger alkyl group is used over here. What if we take a lower group like for example CH3 group? So let's check this one. If we have a CH3 group, then CH3 whole twice NH, and if I take CH3 NH2, and if I take CH3 whole thrice N. Okay, so what is this? This is your secondary amine, this is your primary amine, this is your tertiary amine. Over here also, if you take a lower alkyl group, then what do you see? The secondary amine is more basic than your primary amine, than your tertiary amine. So what if you take a bigger alkyl group, then your secondary, and in your low alkyl group secondary, in both the cases the secondary amine is more basic. But if we take a bigger alkyl group, then the second one will be your tertiary amine, bigger number, big. Lower alkyl group, lower number, that is your primary amine will be the next basic primary amine. So I hope till here everything is very clear. So in gaseous phase, where solvent effect is missing, the basic strength will be your 3 degree to 2 degree to 1 degree amine. But if the aqueous phase is there or the solvent phase is there, then the story will be different. Okay, if the alkyl group changes, then also your story differs. What it is, then in that case your secondary amines are always more basic than your primary or tertiary. To follow on, we need to check the bigger alkyl or the low alkyl. If it is a bigger alkyl, then the second place will be taken by tertiary, and if it is low alkyl, the second place will be taken by the primary amine. Now we next move to the effect of substituents on the basic character of the aromatic compounds. Now we are going to talk about the aromatic, the basic properties in the aromatic compounds. Yes, coming back to basic character in aromatic amines. Okay, so let's check this. Let me write down the first point, that is some electron donating groups. Let us first recollect what are some electron donating groups. For example, your this, okay, then your CH3 or even your OH, they always increase the basic strength. They increase the basic strength. Okay, always remember the electron donating groups, they always increase the basic strength. Whereas what about the electron withdrawing groups? Let's take certain examples. Electron withdrawing groups such as say X, or the halogen, or NO2, or maybe CN cyanide, or maybe sulfonic group, or it could be COOH group, or etc. Okay, to understand that they always decrease the basic strength. They decrease the basic nature or the basic strength, whatever we can say. Is this clear? So electron donating groups, they increase the basic strength, whereas electron withdrawing groups, they decrease the basic strength. On the basis of this, let's check one example like NH2CH3. This is more basic. Okay, this is more basic than your aniline, isn't it? NH2 and aniline will be more basic than that particular group NH2 which has the electron withdrawing group, that is NO2. So this first point is very clear to all. We move to the second point now. The basic weakening effect of electron withdrawing groups and the base strengthening effect of the electron releasing group is more marked where at the para position than at the meta position. So seeing to this point, what did I say? That the base weakening effect of the electron withdrawing groups and the base strengthening effect of the electron releasing group is more marked where at the para position. So look at this at the para position. This will be more basic than the one which is attached to your meta place. Is that clear? Then remember, every ortho substituted aniline will always be less basic than the aniline. Will always and always be less basic than aniline. So let's take one example of this like NH2CH3. This will always, because it is placed at ortho, so it will always be less than the basic nature will be less than the amine over here. Okay, so to bring both these second and the third point together, thus what can we say with respect to these two? The first one, that is, what is the name, IUPAC name of this compound? 4-methyl benzamine. It is more basic in nature than your 3-methyl benzamine. Okay, and this will be lesser than your aniline. This will be more than your aniline, more basic than your aniline, and your least basic will be which one? When your methyl group is present at the where? At ortho place. Okay, so this is your para place, this is your meta place, and this is the ortho place, and this is your aniline. So this is what is the sequence of your basic nature of in the aryl amines. Okay, with this we wind up today. Rest other chemical properties I'm going to come up again in the next video. Till then.